Hello, everyone. Thank you for joining today. We all hope everyone's doing well and staying safe and healthy. I'm David Nakashi, and I'm here with Jen McConnell, our product manager. As many of you probably already know, AXON is our new powerful machine vision platform. It analyzes a stream of live STEM or TEM images, and by controlling the TEM, it compensates for movements in the X, Y, and focus, all while loading the images with metadata from the TEM, camera, and in situ systems. Our previous webinars have covered many applications that demonstrate these capabilities. So if you have an opportunity to take a look at some of those on our YouTube channel, please do so. There's a lot of great information there. So although we designed AXON for in situ applications, these capabilities are applicable well beyond just these techniques. So today we're going to do something a little bit different than we've done in the past. This is a short webisode on how AXON can be used to help facilitate remote collaborations in the TEM lab. So throughout the webinar, if you have any questions, feel free to use the doc over on the side of your application. Type those in, and if there's time at the end, we're going to take a little bit of time and try and answer as many questions as we can. So again, thanks very much, and Jen, take it away.
Thanks, David. Hi, everybody. Like David said, my name is Jen McConnell, and I'm a product manager here at Protochips, and we wanted to welcome you to what we're calling our next installment of our AXON webisode series. And today we're going to be talking about remote collaboration in the new normal. So let's get started. So while this slide is really not news to anybody, it really does kind of set the stage a little bit, I think, for what we're going to talk about. We know research is inherently a very collaborative activity. Gathering people together with different areas of expertise in different areas, excuse me, in hopes of discovering a novelty or finding a breakthrough that fosters improvement. And whether the expertise is in equipment operation or a scientific application or data analysis, each person in this research effort plays such an important role due to the depth of their knowledge in those specific areas. And as most of you know, it's absolutely more efficient to get together, physically in person in the lab to exchange information. But unfortunately, this is not so easy anymore. And even for those who are just working down the hall from each other, it's kind of difficult still. The TEM lab also does not look the same. Universities and industry alike have had to adapt to this new normal filled with distancing and remote activities and an insane amount of virtual meetings and the like. So it's no surprise that the TEM labs have made their appropriate adjustments to keep people safe as well. We're hearing a lot from our customer base that there are capacity limits, and that's reducing the number of occupants allowed in the lab a lot of times down to only one, which would have to be the TEM operator by themselves. Those with more lenient capacity restrictions are still not allowing outside visitors on site though. And due to increases in cleaning and sanitizing procedures, the time available at the TEM lab has been reduced. And so whether the reduction is in the number of hours per day or the number of open days per week, the limited time is delaying the onset of experiments, and it's breaking up experiments into multiple sessions. So the unavoidable reality becomes the disconnect between researchers and their research tools. And so it's forcing everybody to come up with a new approach and consider new ways to do this. So in trying to adapt, a lot of the TEM core lab facilities are doing their best to give customers an experience that best replicates one of being in person. And they're doing this by using different remote platforms. And with so much technology these days, such as Skype and Zoom and Teams, et cetera, you would think that remote sharing a TEM session should be pretty straightforward, but it's not. Many core labs have regulations in place to keep their TEM safe by keeping it isolated from the internet. And so with no connection to the main TEM, that whole idea of straightforward remote sharing and remote collaboration, takes a downturn. So now what do you do? Overcoming these barriers has required a little bit of creativity. A lot of people are setting up something like a phone or a tablet on a stand and presenting a live stream via something like FaceTime. Maybe they're doing it via YouTube or something similar. But this is still very limiting. You know, can you even resolve all the detail on the computer monitor? And then this limited view that you have, is it even enough to engage in a productive experiment? So these types of interim steps, you know, may get you by for a short period of time, but they can be very frustrating, and it would only be for limited types of engagements. It just doesn't adequately replace the connection of an in-person event. In addition to the experiment setup, you know, there's a huge challenge with data transfer as well. Cameras these days are spitting out terabytes of data in the blink of an eye, and not everyone's set up to transfer and receive that amount of data in their office or their home. You know, things like internet bandwidth and computer space and compatibility with different post-processing software, you know, can limit what the researcher can receive from the TEM operator and ultimately what they can do with that data. And this part can be almost more frustrating, the data transfer, than the setting up of the experiment itself. So in summary, this new world brings a new set of challenges to any collaboration, big or small, and the same situation causes different challenges for each person involved. And so we'll be looking at two different perspectives for the rest of these slides. One perspective being from the principal investigator side, or the researcher standpoint, and they no longer have direct participation in the live session. Watching it occur on a tripod camera over YouTube is nowhere close to being physically present. So many details are lost with image quality, and there's lots of questions that come up and lots of back and forth, and it causes distraction, and no one's really focusing on the experiment anymore. And if the researcher cannot participate properly, you know, decisions may be left up to the TEM operator, who might not have as much familiarity with the sample or the experiment or the desires for the experiment. And this leads to more iterative experiments to capture what's desired. And then, of course, transferring the data, like I was just talking about, is a pretty huge hurdle for many. Now, the other perspective we're looking at is from the core lab personnel, such as the TEM operator or the lab manager. And for them, it's difficult to sacrifice the TEM safety for screen sharing capabilities, making a streamlined process for remote sharing very difficult to implement. And because of this, billable hours start to decline without a good solution. And you know, this could lead to things like personnel or equipment sacrifices as well. And any ad hoc remote experiment is likely going to require more resources remotely than in person with some of these setups, especially in situ, whether it be gas or heating or stress and strain. This usually requires more than one person, one to operate the TEM and one to run and monitor and track the in situ. And so, and with any experiment in the end, there's a ton of data that needs to be sorted and organized and annotated. And with these remote sessions, this now becomes the burden of the operator themselves, so that they're sending a complete package to their customer. So how can core lab personnel most closely replicate this in-person experience and collaborative TEM sessions under today's social distancing guidelines? And how can the scientific experts, principal investigators participate in their projects and quickly access experimental data? These are kind of the two main questions both sides are posing at this point. And we think we can help. Our new AXON software takes those devilish details that make the remote sharing incredibly frustrating and eliminates them. Whether you live down the street or across the world from the lab you want to collaborate with, AXON can make it a much more straightforward and enjoyable experience for everyone involved. And for the rest of the slides, we're going to be following our application scientists, Xiaoxi at Shanghai Tech University in Shanghai, and Kate here in the US, Rainer in Berlin, and Yaofeng in Tokyo, as they share an in situ experiment together. So how can AXON benefit remote collaboration? We feel there's several points that can benefit both parties involved, the principal investigator, researcher side, and the core lab personnel. One being that AXON can provide a safe internet connection point to the lab that doesn't require networking to the TEM computers. Two, it provides a consolidated TEM dashboard with the live view of the TEM screen and all the experimental parameters in an easy, shareable single screen for the audience. The AXON data packages are far smaller and easier to share remotely. And AXON comes with a free notebook application so that all collaborative parties can download it and use it to review and annotate the wealth of data that's coming from AXON. So just a quick review on what is AXON in case you are unfamiliar. AXON connects the TEM, the detectors, the in situ systems of ours if they're available in your lab, and does an automated physical and digital image correction while doing parameter integration in the background. So it's like an extra set of hands that does all those tedious tasks for you. And in this example here, make sure it plays for you. We're showing a bulk stainless steel sample in a bulk heating holder with AXON engaged and with AXON off. And so AXON is working with the TEM to stabilize the sample physically in all three X, Y, and Z planes. And then it performs a finishing touch digital correction, all live and all in real time. So what you're seeing is a perfectly still and high resolution image. In addition, again, all TEM experimental parameters are embedded in the metadata of each image. And so ultimately, your experiments become more hands-off while providing you with much higher quality data on the first try than can be done manually. And like David mentioned, we have several webinars on AXON. We've done several in the past. And so you can see our YouTube page and website if you want more details about the nitty-gritty and how it works. And just to give kind of a high-level overview of what AXON looks like in the lab and how it connects, the AXON computer connects and integrates with your TEM computers and your camera computers. And it allows a point of internet connection that's one step removed from your protected computers. So from there, you can use your favorite screen sharing software to share the AXON dashboard screen with the audience. This allows participants to not only see what's occurring on the TEM or the camera, but it also displays all the experimental and imaging conditions. So the audience is very well informed throughout the entire experiment. After the experiment, AXON can export your data already drift corrected and synchronized in small transferable packages that are viewable in the AXON Notebook offline at your convenience. So diving in a little bit more to those benefits of AXON for remote collaboration, starting with providing a safe place to connect to the internet. This one's pretty straightforward, but again, AXON provides a nice safe intermediary for enabling this connection to the internet. And here you can actually see the AXON controller located above the TEM controller, and it's mirroring what's on there, but it makes creating that connection much safer for the laboratory. So now that you're connected, the next step would be to try and consolidate all the important information for the audience. The AXON synchronicity module takes the most important pieces of the experiment and consolidates it into a single screen. So the software shows a live view of data where the images, again, have already been physically and digitally corrected for any drift or movement. You can see all the TEM parameters and the in situ parameters if you have them, again, giving your audience a full understanding of the conditions at any point in time in the experiment. And the operator is able to do an on-demand live review of everything captured at any point in time, which would give the audience a nice high-level glance of what has been accomplished in the experiment, making it easier to decide on the next steps while the session is in progress. So again, looking at some of these benefits towards the two perspectives that we're talking about. For the principal investigator or researcher side, getting that live experimental dashboard where they can easily keep up with the conditions and the images in a single glance is incredibly helpful in keeping everybody aligned. What they're seeing, again, since it's already corrected for drift or movement, gives them lots of high resolution detail to make decisions in real time. And again, these educated decisions lead to less iterative experiments to achieve the final goal. From the core lab personnel side, this single screen sharing, a single screen that shares everything to the customer, again, gets everybody on the same page and prevents all the back and forth of questions and distractions. And then the decisions can be made collaboratively. The researcher has everything they need to guide the TEM operator to what they ultimately want. And as a side benefit, due to all the automation, AXON is, since it's physically correcting and digitally correcting, more advanced experiments like in situ become easier to accomplish with just one person and one set of hands. So to give you a little bit of an example here, here's an example from our TEM laboratory at Shanghai Tech University in Shanghai, China, and we're performing an in situ experiment that's being shared with our app scientists in Tokyo, in Berlin, and in the US. And on the screen, you see what I've been calling the consolidated dashboard. And you have the option of displaying, again, a multitude of in situ and TEM parameters on the screen for the audience. And you can choose any number of these from the drop downs that are located in the menus within AXON. There's also a summary of the detector, magnification, frame size along the bottom for you as well. During the experiment, you can tag sections of data. Note we're tagging a section here we called it reacting. And this allows you to mark data as important and allows you to export that tag data into a separate folder for easy finding later. You may want to use this when you see something interesting beginning to happen, or if you believe the reaction is about to occur or take place. And this will allow you to find this section without needing to dig through data later. You'll also see in just a bit how this drastically improves how data is transferred, since you're cherry picking only what's most important for you. Now again, after a few hours of experimentation, it becomes easy to lose the big picture of what's already occurred. And so when the question pops up, so do you have what you need? You know, the TEM operator can do an on-demand data review of everything that's been captured, so that the audience can be reminded and they have a clear idea of where the experiment stands before the session continues or ends. So you just click Review Session, and on the dashboard, and then the AXON Notebook app pops up with all the data loaded in it. You can use the scroll bar to scrub back and forth, reviewing everything from the session as either drift corrected or raw images. And here again, you can add parameter overlays so the audience is aware of the conditions of the data being reviewed. As you can see that they change as you scrub back and forth through the data. So again, this on-demand review enables the audience to come up with educated answers to questions like, what do you want to do next? Can we end the session or do we need to continue? So now that we are connected to the internet and we've got a way of sharing the live session in a consolidated fashion to the audience, how do you ensure all of those details don't get lost after the experiment is over? So the AXON Synchronicity module automatically integrates all the TEM and in situ parameters into the metadata of every single image. All the overlays we were looking at, everything in those drop-down boxes, all of that is being integrated in the background in real time. So manual tracking and alignment of dynamic parameters is a thing of the past. So when you look at this again from those two perspectives we're focusing on, from a principal investigator, researcher perspective, there's more accurate reporting from a more complete data sync. And so with it, there's more, it's more accurate because they've got all these details that typically are not accessible when you're trying to take notes manually. They're able to more effectively draw conclusions between the TEM images and the experimental data. Again, you've got such a complete data set and so much information to use. And because it's all being done live in the background, in real time, you receive your data after the experiment's over very quickly. From a core lab personnel perspective, they're able to focus on the customer. You can focus on the customer and the session instead of taking notes. There's less multitasking then, which of course means fewer human errors. And you greatly reduce the time that's required for manually organizing and aligning all of the data and parameters before delivering it to your customer. And by greatly reduce, I mean you eliminate it. So let's take a look at just how straightforward this is. When you're ready to export the data, you can choose from several different options, and I'll start the video in just a second. You can export the entire session or just the tag sessions. You can opt to include the overlays, export the raw or the drift corrected, or both. And then AXON will take that data and put it in a folder for you. All the metadata is in each image, and you get a CSV file with every parameter organized into columns. And here what you'll see here is an export of only that tag session that we looked at earlier. And they chose only to export the drift corrected images. And then you can see it, because it's such a small subset, they're able to immediately upload it to the cloud for sharing. And it's as simple as that. And meanwhile, while they're doing all of this export, AXON is still recording and synchronizing what's going on in the TEM in the background. The ability to tag a subset like this of data completely changes the file sharing interaction. Your data packages are tens of gigabytes instead of hundreds of gigabytes. And so you can immediately upload it and share. This removes the burden from the operator to align everything just for a subset of data to quickly send. And it satisfies the researcher with a quick and accurate data set. So now that the experiment's over, the data has been sent to the interested group, it's time for some in-depth analysis by the group on their own. And so how are they going to accomplish this? So the AXON Notebook application enables complete offline analysis so each stakeholder can perform their own detailed review. The AXON Notebook app is a free download, and it allows easy viewing of all the process data, and it allows you to add those overlays and prepare for presentations and publications. And the Excel workbook of all the parameters allows for more in-depth trend analysis than you were ever able to accomplish before, because there's a multitude more data there than you typically would get. So again, from our two perspectives, the principal investigators, this point can't be hammered home enough for them, it seems. The data comes so quickly and it's already organized and processed and aligned. They're able to use the Notebook app to prepare high-res images for publication efficiently with all the overlays they can add. And all the stakeholders can be more involved in the project, because with data sets that are small, the limitations that we mentioned earlier are not so prevalent. And the AXON Notebook app is free to anybody that wants to work and collaborate together. So they can take the same data package and get the same amount of information. And so everybody can be more involved. From the core lab personnel side, there's no requirement for them to convert the data into a format that may be more compatible for their particular customer. And of course, with all that information that's being sent, they're minimizing the back and forth that may occur afterwards with questions about different parameters, and so the customer is fully informed, and you reduce that back and forth. Here we're going to see Yaofeng is going through his own analysis of that tag section of data that we collected earlier. And he's able to open it up in the AXON Notebook app, which looks very much like the dashboard from the experiment. And here you can add overlays to create images for publication, or you can just add them for information while you scroll through the data, because you'll see they update continuously as you scroll. This really gives you a chance to explore the reaction that took place and observe all areas of the sample and detail you may have missed during the experiment. The CSV file containing all TEM and in situ parameters that comes with the export allows you to manipulate the data within Excel for graphical analyses, trend analyses. You can filter, create pivot tables, etc. But you can also use that CSV to generate more advanced graphical representations of metadata to make trend spotting easier for you and convey information more clearly. In this case, you see Yaofeng is able to plot actually in 3D the X, Y, and Z movement of that copper catalyst particle over the course of the experiment. Axon's drift control is constantly, in order to be able to do the drift control, it's monitoring the movement of the particle too. So you get to create plots like that to study dynamics. And so the organization of the images and the metadata really allows you to, ultimately get to your goal faster. That's what we're trying to help with here. And so AXON provides what we feel is an obvious solution to remote collaboration and more. There's increased opportunity for your principal investigators and for your researcher groups. You're able to secure the use of quote unquote restricted resources. You can't go visit in person, but here now you're able to take advantage of these tools. You have real-time collaborative decisions that greatly can shorten experiment times. And it also reduces the need for multiple experiment iterations between the system automation and the depth of detail you have during the experiment. And of course, you can publish far faster. Your data is much more rich, and you're able to create immediately different types of visualizations to share and to present and for further analysis. There's an opportunity for increased effectiveness and efficiency for core lab personnel as well. You're able to potentially expand your user base because your experiments are faster, there's fewer system delays. Of course, the increased productivity of your staff and all the available tools. And the collaborations allow experts, quote unquote, in the room to assist the TEM operator for every sample run, again, accomplishing the goal faster. And it enables novice researchers to engage your TEM experts, to progress their projects along faster. So in summary, remote collaboration is something we need to adapt to now because of the circumstances we're all in. But who's to say, keep going, who's to say it won't stick around, with AXON as a streamlined solution as a new permanent normal? So looks like we are right on time. Thank you guys all for joining our short little webisode. I hope it's inspired you to, talk to your core labs and, talk to your user bases and see if we can help with AXON and get you guys together more frequently in a more streamlined and effective fashion. So thank you so much. We got a couple minutes. Let me see the question box. And if we've got a couple questions, we'd be happy to answer them. So let me pull that up. David, if you don't mind, maybe I might ask you to help me answer a question or two.
Sounds great. No problem. I'm ready.
Okay, thanks. We do have a couple. So let's see. How large are typical file sizes that are recorded and transferred using AXON?
Yeah, that's a great question. You touched on this a little bit during the presentation. So throughout the course of an experiment, AXON is always taking the live images and the metadata and saving it off into the drive on the AXON core. But one feature you mentioned is this tagging feature, and the tagging feature allows you a user to tag sections that are particularly important to them that they may want to transfer later. So in other words, if maybe over the course of an experiment that say ran for an hour or 2 hours, there was a particular segment, they could tag that segment, and it's basically set aside in the software, and then that can be identified and more easily transferred in its own succinct little package to the end user. If that tag section is a matter of minutes, it could be only a couple of single gigabyte file sizes. If it's 30 minutes, an hour, it could be in the tens of gigabyte file sizes. And so I'd say in general, probably tens of gigabytes, which is certainly a much more manageable size file than say the hundreds of gig or terabytes that people are used to.
Perfect, thank you. Let's see, we can do one more quickly and then we'll let everybody go on to their day or their evening. Can you clarify further the internet connection that's needed in my lab for AXON?
Yeah, that's another great question. It's one that's pretty important to the message of this webisode. So in the TEM lab, basically, there's either one or two main computers. One of them is managing the microscope itself, and you may have a second one managing the imaging system or camera. And so AXON connects within the lab through an intranet to each of those computers. And so basically that's how it's getting the images that it needs to do any of the real-time corrections and drift and focus, and then controlling the microscope to make adjustments with the goniometer to keep everything stable and in the center of view. Now that's all done in an intranet behind the intranet itself. And so on a separate NIC, network interface card within AXON, that's the part that interfaces to the internet on the outside world. And so basically the benefit there is that you can share a screen that has the live view from the camera or STEM detector, as well as the experiment data through the AXON core without needing a direct internet connection to the TEM or the camera computer. So basically, again, the internet connections are the intranet, which connects the AXON core to the camera and the TEM computer, and then an internet connection only to the AXON core to facilitate an outside user actually seeing their dashboard for the TEM session. And again, the great thing there is you don't need the TEM camera computer, or you don't need the TEM computer itself connected to the internet.
Perfect. Thank you. We promised them a short webinar, and so it's been 30 minutes, so we'll let everybody go. Thank you so much for joining us. If you didn't get to your question, please enter it into the question box, and we'll be happy to reach out to you individually to make sure we answer it. But yes, thank you so much for joining. We hope the rest of you have a great rest of your day, your night, your afternoon, wherever you may be.
And thanks everybody. One thing I want to mention in closing as we sign off is AXON itself has quite a few applications, as it was designed as a machine vision platform for not just in situ microscopy, but microscopy in general. And we've done a number of these webinars over the summer, and many of them are applications based. And if you're interested in seeing how AXON can be used with specific applications, please visit the Protochips YouTube channel. And we have a variety of experience videos that go into detail on the software. We have other webinar sessions that explain some applications, and those are again uploaded on the Protochips YouTube channel. And you're welcome to take a look at those at your leisure. So thanks very much. We all appreciate it. Thanks, Jen, for giving the presentation, and we hope to hear from you. Thank you very much.
Thank you. Bye, everybody.
Bye-bye.